Good morning, sir. Hello, sir. So very good morning to all. Am I audible?
Good
Yes,
morning,
sir.
sir.
Good morning, sir.
So screen is visible.
Yes, sir. It is visible.
Okay. So I think in the last lecture we discussed about how to find out the surface integral, line integral, as well as the volume integral. If there is a surface given to you, and we are trying to find out the surface integral. So it's basically the addition of the small surface or the small line to find out the overall output of the surface, or it may be in terms of the line. Okay, so we are taking one example in terms of the one cube, and cube have some boundary which is some kind of a vector is given, and this vector is moving in a edges of your this cube. But whatever the path they are following, this path is nothing but a closed loop path. So that's why it is called as the circulation of the vector f. So if I open this closed loop integral, then it becomes a, sorry, if I open this closed loop, then you can write down the addition of all the integral with respect to the different path. So we try to find out the for the path 1, path 2, path 3, as well as the path 4. So basically the closed loop path. So we are trying to find out the closed loop integral of f dot di. So whenever we are taking the 1 and 2, so basically it's a movement of the x as well as the y direction. Either it may be positive or it may be negative. But if you see the 3 and 4, this path or this line is located in one of the surface. So you must have to take the differential distance, which is depends upon the two parameter. For the path 3, this is a in terms of the x and in terms of the z. Okay, and for the path 4, which is in terms of the d z and the dy. So di is basically dz az plus dy ay. So if you multiply this di with whatever the f is given to, we can try to find out the 3 and 4th integral. And if I add all this integral, you may be getting the final answer is minus 1 by 6. So now we are moving towards the next part is what is the del operator and why it is useful if I multiply with any scalar components as well as the vector components. So maybe you are knowing the sign, which is nothing but a del operator is the reverse triangle. It's a some kind of a vector differential operator. So already you are knowing the del by del x. Normally it is the d by dx, but in this case they are mentioned as a del by del x. Okay. So del operator, it's a some kind of a differential operator in terms of the vector form. And this can be represented in terms of the Cartesian coordinate system, which is also the vector where del is equal to del by del x. So it's a basically d by dx, but this movement is only the x direction. So that's why they are considering the multiplication with a of x. So if you find out the d by dx, definitely its answer is in terms of the magnitude part. So it's a magnitude into a unit vector ax. So can I consider the vector form? Del operator is basically vector form. Same way, if I am consider the movement in a y, so it's a d by dy. So we can mention the del by del y into the ay and plus del by del z into the az. So this is the overall vector representation for the del operator. Okay. So now already you are knowing, suppose you have some scalar components and you have some vector components. You have some scalar components as well as you have some vector components. Then if I multiply this two vector, based on the multiplication, it will be generate some answer in terms of the vector or maybe in terms of the scalar components. Okay. So first one is if I multiply the del operator with any kind of your scalar components. Suppose the any temperature is given which may be a scalar components, and if I multiply with this del operator this terminology which is considered as the gradient of the scalar. Later on discuss what is the meaning of the gradient of the scalar, but it's a basically a simple multiplication, not a dot, not a cross. So if I multiply the any scalar components with a del operator, it gives me the gradient of the scalar, which may be represent with del v sign, which may be represent with a del v sign in a first one. But if instead of this scalar components, if I multiply with any vector components, now you have a two vector. One is del vector, which is mentioned on your screen, and we are taking another vector, which is nothing but a b c d, whatever the vector you are taken in terms of the any coordinate system. So you have a two vector. If you have a two vector, definitely answer may be in scalar or it may be in terms of the vector form. If the answer it is in terms of the scalar components, then it is considered as a diversion of a vector field A, which may be represented with a del dot A. Remember, there is a difference in terms of the del V and del A, del dot A. If you are getting the any dot between these two vector, then it is always the diversion. If you are not getting the any dot between these two vector, definitely V is not a vector, it's a some scalar components, then it is considered as a gradient of the scalar and the diversion of a vector. But same way, already you are knowing if you are taking the two vector, the resultant vector may be in perpendicular to this two vector, that definitely it is considered as a cross product. So if you are getting the answer which is in terms of the cross product, then it is considered as a curl of a vector field A. So if you concentrate the 2 and 3, if you concentrate the 2 and 3, it's a basically both are the vector. Del is also vector and A is also the vector. And based on the answer, it may be scalar, it may be vector. So we can represent with one is the diversion of a vector and second is the curl of the vector. Now what is the difference? If you find out the diversion, it gives me only the magnitude part. It gives me only the magnitude part. But if you find out the curl of any vector field A, then it gives me magnitude as well as the direction. This is only the difference. Clear? And same case, if we multiply with any one of this one, if you multiply with any one of this, like a del v, which may be multiply with del dot a, if I multiply the del cross a, then the resultant answer which is considered as a Laplacian of the scalar field a. Okay, now just consider the first three terminology and the last terminology, which is the Laplacian. Is there any difference? Hello, is there any difference? Yes. Any answer from your side?
Just we have to
If we
square the del
can,
operator.
okay, so what is the meaning of the square over here? See, this square is getting from where? This is only the, if I'm taking the like a second time, like a del v, two times we are taking the del. Okay, so there's a three different option. Exactly, there is a 3 factorial because we have a 3 equation. One is del v, second is the del dot a, and third is the del cross a. So any one of the possible combination will be there. But out of the all the possible combination, only one is survive, rest all are the zero. You can also verify with the one, we are taking one example and you maybe verify the results. Only the one is survive, which is the del v, which is the diversion of the gradient of the scalar. Okay, so if I'm consider the first equation, gradient of the scalar v, and if I multiply with another del operator, then what you are getting? Del dot del v. Okay, now all of you just mentioned del dot del v. Whenever there is a dot, it means it is a diversion. So the Laplacian of the scalar is basically what? It's a diversion of a gradient of any scalar component. It's another representation, diversion of the gradient of any scalar components. Clear? So if I'm taking the diversion of this first equation, you may be getting the last one. What is the meaning of the del square over here? Nobody knows?
So double differentiation of d
Yeah,
square.
it's a basically second order differential equation. Maybe you are studying a math subject. It's a basically a second order differential equation. If you see the first three, it's a basically first order differential equation. And the last is the Laplacian of the scalar field A, which is considered as a second order differential equation. Now it may be question, what is the difference of the first order and second order? Why we are taking the first order, or why we are going for the higher order, like a second, third, fourth? Any answer from your side? Second order differential equation means what you are understand, because so many times you are trying to find out the second order differential equation. No idea? If I give the simple example, suppose consider there is a one line. This line is having a length is approximately 1 kilometer. Okay, and you are taking the this line is located in a x-axis, and you are taking the first order differential equation del by del x. So exactly what you are getting, whatever the wire you have from approximately 1 kilometer, you just degraded this length of this wire to find out the appropriate output of this individual length of this wire. So what we are doing, like a 1 kilometer is just divided into 100 meter, 100, 200, 300, 400. Okay, so we are trying to find out from 0 to what 100 meter, what is the output. For 200 to 300, what is the output? So basically what we are doing, we are just degraded our length of the wire to find out the output. This is the first order. Suppose if I'm taking the second order, it means now you have a 100 meter only, because I'm taking the random, it's a 1 kilometers total and they divide into a 100. So now you have a 100 meter. 100 meter is further divided into a small part. It depending upon the del x parameter, how you are taking the del x. Del x means two differential parameter, 2 points, x2 minus x1. Okay, so what we are doing, we are just minimize our length of the wire to getting the more accurate result. Okay, so it's by obvious, if you go for the higher order, your result is very accurate compared to the first order. Okay, but it doesn't mean that like a you are just increasing the number of order, like you are taking the number of order is 10. Okay, so after the sum orders, there is a nothing is reflected in your output side. Nothing is reflected in an output side. It means this is the minimum order you can take, or maximum order you can take for the maximum accuracy. Okay, so this is the difference of the second order as well as the first order differential equation. So our now more focus, we are trying to find out the gradient, divergence, and the curl, and the last one the Laplacian of the three different coordinate system. It's a very essential to understand what is the meaning of the gradient of any scalar components. Clear? So is there any doubt for only this four different parameter right now?
No, sir.
Okay, so now we are moving for the first parameter, which is nothing but a gradient of the scalar components. I'm not going to detail of this all the equations. You may be just bored, but it may be required when you are try to find out the gradient of the scalar. So I'm directly going for the book. You may be very easily understand for this part. Getting the screen?
Yes, sir.
Okay. So first we understand what is exactly the meaning of the gradient of the scalar components. Okay. In your seeing, you are in your screen, you are seeing some kind of a irregular circle. Can you tell me what is this? Any one of you? Hope so all of you are getting some irregular shape on your screen. Any one of you are knowing what is this? I'm talking about this irregular circle. It's a basically contour. This is called the contour. Okay. For the circle, it's almost each and every direction you are getting the similar in terms of the radius, but for the contour, you may be some irregular shape, but it is a closing, starting and ending point all are same for any one of the contour. Okay. So what we are doing, first of all, we are taking the X, Y and Z axis. First, we are taking one contour which is mentioned on your screen, which have a some volume which is V1, which is nothing innermost shape of your figure, like a V1 is mentioned. This is called the contour 1. Second contour, they are considered as a V2. And the third contour, which may be considered as a V3. This part is clear?
Yes, sir.
Okay. Now, what we have to do, we are taking one point which may be located in a V1. It means any one of the contour. Right now, we are taking the first contour V1. So the point which is located, it's a P1. Okay. So all of you are maybe getting your point which may be located, it's a P1. Now, our target is you can choose the any point. You can choose the any point from the contour V1. Our target is from the P1 point in a contour V1, I am interested to move in a contour V2. I am interested to move in a contour V2. So can I consider there are infinite possibilities? Yes or no?
Yes, sir. It
Yes, sir.
can be.
From the P1, I'm interested to move to the contour V2. So see, this is P1 which is located on a V1. So from the P1 to any one of the point in a contour V2, it have a infinite possibilities because this contour V2 have a so many points are available. Okay. So our target is from P1 to the any one of the point which is mentioned with a P2 in a contour V2. Okay. But you have to only move whenever the distance between these 2 points, which is the maximum one. The distance from P1 to the any point on a V2 contour, which is the maximum one. Okay, so all of you are getting this from P1. If I'm moving in a Y direction, the maximum distance should be there. Yes or no?
Yes, sir.
Okay, so we are interested in this part. We are interested from P1 to P2, any one of the point where there is a maximum space rate are there, which is called the space rate because the V1 and V2 is filled up with some kind of a free space. So this is called the maximum space rate. Same case, suppose assume from P2, we are interested to move from P3 in a contour V3. You can choose the any one of the point for the P2 and you are moving from P2 to any one of the point in a contour 3. But whatever the point you are selected, you must have to take this point, which is the maximum space rate. It means from P2 to P3, the distance should be the maximum one. Okay. So by obvious from this location, if I am seeing where it is mentioned with a V2 is equal to V1 plus delta and you are moving from V3 in V3 direction where the V3 is mentioned. This distance is slightly larger compared to the any one of the distance. Okay, so it is only possible whenever if I adding a some volume or differential volume part which is mentioned with a del v. It means we are taking the small part and we are adding with a v1. So v2 is equal to, they are mentioned with a v1 plus del v, and you can also mention v3 is equal to v2 plus del v. Clear? So if I'm moving from v2 to v3, I can mention v3 is equal to v2 plus del v. So this is only the way whenever the maximum space rate is increasing, or it is a direction at which the maximum space rate is increasing. This is called the gradient. Now tell me, any doubt in this particular figure? Exactly what we are trying to find out. Now we are moving for the equation part. Is there any doubt? Tell me at least yes or no.
No, sir, not up till now.
Okay, so now you are getting the idea what we are targeted for the gradient of the scalar. Why it is gradient? Because see, v1 is the some magnitude part, v2 is also some magnitude part, and v3 is also some magnitude part. Okay, but if you find out the answer of the gradient of v1, v2 and v3, the answer is the vector. We verify it. Why it is vector? Because see, from p1 to any one of the point is p2. So basically you are selected any one of the direction for the movement of p1 to p2. Okay, so this is the direction, and the movement from p1 to p2, which is nothing but a distance, which is mentioned with a del v over here. This is nothing but a what? It's a magnitude part. So if you find out the gradient of the scalar value, the answer is always in a vector form. Okay, now see how you can find out. So whenever if I am considering the point which may be in a contour v1, and we are trying to move in a any one of the point which is the in a located in a contour v2. Okay, so basically this movement with respect to any one of the possible combination, either x, either y, or either z, because we are taking this del by del x, del by del y. This del v is what? It's a del by del x in a specific direction of the x. Okay, so what we can mentioning, you can write down this dv. Dv is basically what is the differential volume parameters, or you can consider the differential scalar components. If I am taking the difference with respect to x direction, then it is del v by dx, del v by del x into the dx, plus del v by del y into del y, plus del v by del z into the dz. This is a vector calculation from the method of separation of the variable. Maybe study somewhere else. Method of the separation of the variable, which is nothing but a what? There is a no effect of this. Suppose if I removed this equation del v by del y into dy plus del v by del z into dz, no effect with this dv. Why? Because see, del v by del x into dx. So dx and del x will be cancelled. What you are getting? Del v. Del v is similar to dv. Similar, consider the x term in this equation will be 0 and z term is 0. And the only value del v by del y into dy. So del y and dy is cancel out. What you are getting? Del v. Del v is similar to your dv and similar for the z. So this calculus, it is indicate for individual parameter, your output will be the similar one. Okay, so this is a equation which is coming from the calculus, and we are trying to find out the del by del x into dx. Okay? Now same equation can be represented with another way. What they are taking, because already you are knowing this del by del x into dx, these are the movement in a x direction. Second term is the movement in a y direction, and the third term is a movement in a z direction. Okay, so I can mention this del by del x into ax. Why it is ax? Because you are knowing it is a movement in a x direction, so you will just multiply with a unit vector is ax, plus del by del y into ay, plus del by del z into az. Okay, and we are taking the dot product. Can anybody tell me what is the meaning of this dot product over here, which is I mentioned with a blue color? Exactly what is this?
DI.
Yeah, it is DI. All of you are seeing this is the DI. DI is basically your differential displacement. Why they are multiplied with a DI? Why they are not multiplied with a DS or DV? The reason is you can see this figure. Whenever if I'm moving from P1 to P2, it's follow one path. It's not a surface, it's not a volume. It's only the one path, and path will be represented with a DI, differential displacement. But we don't know you are moving in a which direction, X, Y or Z. So that's why they are multiply the general term. General term means it may be function of X, it may be function of the Y, it may be function of the Z. So that's why this is DI, differential displacement for the Cartesian coordinate system, which is nothing but dxax plus dyy plus dzaz. Now if I just multiply these two and tell me you are getting the similar answer, which is mentioned in the above equation. If I multiply this two vector, why it is vector? Because see, it have a multiply with a ax, ay, az. So di is vector, di is a differential displacement is also vector, and whatever the another term you are selected, which is also the vector. So it's basically what? If I multiply this to what you are getting? Any one of you are?
The first equation.
Yeah, it's a first equation because the first term del u by del x into ax, and if I multiply dx into x, so ax dot ax becomes 1. Okay, so you are getting the first equation. So there is a nothing is difference. You are just separate out the sum of the differential parameter in another way. Okay, now already you are knowing this is dv, this last term is the di. Okay, these are the some important part where you are taking the differential operator with respect to x, y and z. For the conveniency, what they are mentioning, considering this is the sum of the terminology which is nothing but a g. This is some of the terminology which is mentioned with a g. So what you can write down, dv is equal to g dot di. Okay, and g is equal to this equation which is already mentioned on your screen, which is the 3.25 del u by del x into ax, del u by del y into ay plus del u by del z into az. Okay, g is nothing but a your, what is this? This is the gradient. This terminology which is considered as a gradient of the scalar. Why it is scalar? Because see, v is the scalar components in this equation. Okay, now if I give the simple example, suppose if I'm given the v is equal to x, y and z. Okay, and someone is asking find out this g, use this equation with a 3.25. What you are getting? V is equal to x, y and z. Nobody knows? If your v is equal to x, y and z, what is the answer of the g over here, which is mentioned on your equation 3.25? Suppose v is equal to x, y, z, and you are differentiate with respect to what? It's a x. So what you are getting? It's only y, z. Y, z, ax plus v is equal to now x, y, z, and you are differentiate with respect to y. So what you are getting? X, z. X, z, ay plus x, y, az. Now see this answer, it is in vector form. So that's why they are telling you the gradient of the scalar, the answer is always in a vector form. Okay, so this equation which is considered the gradient of the scalar one. Okay, now they are mentioning the dv is equal to g dot di, and already you are knowing g is the vector and di is also the vector. It means I can find out the dot product. So how you can mention this one? Mod of g mod of di into the angle between g and di, which is nothing but a cos theta. So you can see this angle. Where is the angle theta? You are find out the gradient which may be any one of the direction, and you are following the any path. it may be possible whatever the path you are following and whatever the gradient of the scalar you are following, it has some angle. Both are not a similar. Okay, so di is a differential displacement and the gradient of the scalar is nothing but a maximum space rate. So I can mention g dot di is basically mod of g, mod of di and into cos theta. Okay, so I can just write down the dv by di is equal to g cos theta. Now see, what is the definition of this gradient of the scalar? All of you just read this. The gradient of the scalar field A is the vector. It means if you have a V, which is the scalar, if you find out the gradient, answer is vector. That represent both magnitude and the direction of maximum space rate of increasing V. Maximum space rate of increasing the V. Why it is increasing? The reason is you are selected the any one of the point from P1 to P2, but this maximum space rate you have to select. You cannot choose the point which is very nearer to this one. You have to select the point which is the maximum in terms of the distance from P1 to P2, where P2 is located in a contour V2. Clear? So finally you are getting this dv by di is equal to g cos theta. And this is also called at the directives, normal directives. Okay, so how you can mention this gradient of the scalar using this equation? So all of you just mention this equation on a piece of the paper. Or you can also write down this one. So equation 3.29 means this one. Both are almost similar, but they are mentioning the del v in terms of the del u by del x into x plus del u by del y into ay plus del u by del z into az. Now you can see from this equation, like a dv by di is equal to g cos theta. Suppose assume g is 0, theta is 0. Theta is 0 means there is a no angle difference between the di and g because theta is 0. Okay, so what you are getting? dv by di into the z. So it is indicate whenever the maximum space rate will be generated if I'm putting the theta is equal to 0. Why? The reason is theta is maximum or cos theta is maximum at a theta is equal to 0. So this is called a directives or the normal directives. Why it is normal directives? Because the dv by dn is equal to g, where theta is equal to 0. So this is called the normal directives. Sometime it may be asked find out the normal directives. It's basically only the gradient of the scalar and you are putting the theta is equal to 0. Okay. So is there any doubt for this equation?
No, sir.
Gradient of the scalar. So it's request to all. Already book is uploaded. You just read once, then you may be getting the idea. Those who are not getting the idea, at least read once. Because up to the gradient, diversion and curl, these are the important parameters. Okay, and later on each and every chapter are based on this one. If I know the gradient, if I know the curl, if I know the scalar diversion, or if I know the Laplacian, then I can easily find out the each and every problems. Okay, so I think we discussed up till this. We are not moving to the next one. Okay, so all of you just write down this equation del v, which is nothing but a gradient of the scalar. So all of you are seeing this tutorial one.
Sir, we cannot see the file.
File is already uploaded.
Sir, in which section, sir?
Go to the assignment section.
Sir, only the uploading part is uploaded, but we cannot see any file or PDF.
Already file is uploaded and someone is already seen this file, because if you are seeing this file, I can verify you are seen. Just go to the team go to the assignment section
Yes, sir.
and you may be getting it. Okay. The last deadline you have to submit this assignment, I think it's 9. Before 9 January, you have to submit it. Okay. So there are at least 7 to 8 questions. Yes.
Sir, there is no any PDF.
So I can share my screen.
Yes, sir. There is no any PDF in this.
You are getting the 27 number.
No, sir.
Okay, just wait. I will check right now and I will be informing. Wait for 2 minutes. I'll be check.
Sir, sir, there is a file, tutorial one in
Yeah.
assignment section. Yes,
So
sir,
you are
I
getting
seen.
the tutorial one. Can you share your screen? In the assignment one, it is mentioned with a tutorial. Well, if you are getting it, tell me yes or no.
No, sir.
Just wait, I'll be check. Now all of you just verified.
Yes, sir.
Yes, sir. Now it is visible.
Okay. So you can open this tutorial. Almost similar example which is already discussed in a theory class. Okay, so try to at least solve by your own. The reason is, if you have a physical exam in a GTU, definitely the only example part is there, and if you go with a theory is also the sum of the example. Because see, right, someone is telling you like, I explain the gradient of the scalar, so it's a basically what, it's a mathematical thing. You are not write down the single word in terms of the like a theory. Okay, so it's a request to all, do not copy paste any one of the assignment or any one of the tutorial. If you are copy paste, definitely you are not solving the single example in a GTU exam. Okay, and same case in terms of the mid semester. So if you have any doubt, you just tell me. Otherwise, try to solve within the time limit. And this tutorial have a 10 marks. Okay, those who are not submitted within the time limit, definitely it will be reduced to the 5 marks. If you are submitted after the 9, you may be getting the 5 marks. So is there any doubt?
No, sir.
Okay, so taking the attendance. Okay, your lecture is finished now.
Thank you, sir.
Okay.
Thank you, sir.
Okay.